INDIAai Conversations. Today I have Professor Abhinav Dhall with me from IIT Ropar. He's a professor in computer science, and his team has recently developed this tool called Fake Buster, which will detect fake videos and fake video chats and deep fakes and some of the bigger challenges we are facing these days. So I will let Abhinav explain. Hi Abhinav, welcome to India AI.
Thank you, Jibu. Hi. I'm assistant professor in computer science at IIT Ropar, and I'm also a lecturer at Monash University in Australia. So I have these two research groups across India and Australia, and we are working on different aspects of human-centered artificial intelligence, particularly looking at how we can have AI algorithms using computer vision and machine learning, which can assist and make environments safer for the user or users. And this particular work is around deepfakes. So, everyone now would have come across these sometimes fascinating, sometimes scary deepfakes, like of Tom Cruise or the presidents of different countries. Well, that does show the progress of what we have in machine learning and computer vision. But the same technology can be misused as well. And we realized this about 2 years ago when we saw some high quality fakes, which were difficult to identify when you listen to or you see them. And we thought, well, this is something which we want to work on. And that's where Fake Buster comes into the picture. So that's one of the projects across this Monash IIT Ropar collaboration, where we are looking at a particular use case of where deepfakes could be used by an adversary, by an attacker during a video conference.
So one of the things I came across, it is very much covered in news, right? We India AI did cover it. I seen the same news in Times of India, the Hindu. It's getting a lot of recognition. And one thing I came across is this is one way to identify if you are in a video conference or if you are in a web classroom. It will be one way that you can't how do you say fake your identity. So, what will be the applications? It's very broad when we say deep fake in general,
Right.
but what will be the application Fake Buster can have right now?
Right. So there are different type of attacks which are possible using deepfake. And deepfake again can be an image-based deepfake, a video-based deepfake, or an audio-based deepfake. Now, if you just look at this use case of video conferencing, in this case, what can happen is, so for example, I joined this Zoom conversation by clicking on a link, right? And you let me in, you saw, okay, this person, Abhinav, is trying to join. Now, I could have kept my name as Jibu as well, right? And then someone name would have entered, let me enter in it. Now, what is possible is there are these deepfake generation tools which are openly available. Amazing piece of technology, by the way, but they can be used to create a virtual camera. So what that would mean is I can join as someone else. And if let's say there were N people, now here is where the situation gets a bit serious. Let's say this is an AGM of a company or it's a government department which is discussing something very serious related to COVID, right? Some strategy is happening. And then you see one attacker coming in as a very passive member who's not speaking much, but to all other people, he or she looks like their colleague. Now he has access to information. That's one. And there was a simulated example of this where some researchers, they wanted to show that this is a serious thing. They actually created impersonation of a Russian politician and tried to reach out to some colleagues in the UK through Zoom.
I remember reading about it.
Yes. Well, that was done in all good taste to actually spread awareness, but that can have some very serious repercussions when someone wants to do a damage. To add to this, we are using video conferencing now for online proctoring and online hiring as well, right? And particularly in online proctoring, no, it's not just the students, it's the invigilator who is struggling due to the COVID circumstances. He or she has to, do their job, give a fair platform to everyone else. So there as well, we can have these deepfake generation tools where someone could join as someone else. And we thought, well, from a computer vision perspective, this is a challenging problem since we have streaming data where one could have some artifacts which are generally observed when, let's say, the bandwidth goes up or down, right? So that's a technical aspect. which we would like to take care of, so that when the bandwidth goes down, the video should not be recognized as a deepfake, because there would be artifacts in the video, right? So that was, the exciting as a scientist perspective. The other thing was this use case. We thought, well, if we could show that this is something which is possible, then we would try to judge the interest, and that could give rise to more use cases, so that there can be more industry and academia collaboration. And that is precisely what has happened after the news was published by the respective press information bureau. We have been contacted for different type of use cases and different possibilities. So see, on one hand, I totally support synthetic data generation, which is again deepfake. But on the other hand, the same technology can have a lot of misuses. So we think with fake busters, we can, at least have some type of control when is a larger meeting happening, so that there is no rowdy element joining in, someone who's not stealing an information. There is no espionage happening. So from that perspective, we designed the tool.
I think when we and as AI researchers, we generally get excited when a new milestone is achieved. If whether it's something, as press notice like the AlphaGo's achievement, or something like this. We get excited. But as many powerful technologies, it's a double-edged sword. And since you are mentioning the Russian politician situation, I mean, the potential for harm is much bigger, and the impact of such a harm can be crucial, right? We have seen deepfakes of Donald Trump, right, when he was a U.S. president, and you can have a deepfake of a world leader, and I mean, not every country has an equal level of security and all, right? You can have one African nation's a leader joining in a call, and you have a how do I say, deep fake, giving him message, right, giving him instructions. I mean, that can have geopolitical impact. I mean, such
Certainly.
one cases. So, but generally, what we have seen so far, I mean, we have come across a few deepfake solutions. I think a few students from recently from Nagpur created a
Yes.
deepfake solution where you can upload a picture and it will tell you. But your solution is much more advanced, right? You're talking about live video streaming happening, right? So,
Right.
how does that work?
Okay. So with respect to defect detection, we are looking at not just the prediction part from a machine learning perspective. What we are also interested is how is a user going to digest and understand the information which a defect detector is going to share with them, right? So I don't want, let's say, a detection detector misfiring or simply saying that, okay, this doesn't look like Abhinav, now call out Abhinav in that meeting. See, that could totally disturb the decorum of the meeting. So for us, we look at the spatiotemporal movements, basically very fine-grained movements, which could be either observed as an artifact, then which is added by a defect generation tool, or it could be when you look at a high-quality fake, where when we see or we listen to it, well, it looks like a real video, but then when a network look or neural network looks at it, it would then be looking at it in a higher dimension space, right? It's like getting a big, microscope and then opening the layers of onion and seeing, okay, well, there is a deepfake. So for that, what we did is, especially for this real-time aspect and also for the streaming data, we had to generate and simulate this kind of environment within lab as well. And that took quite a bit of weeks. So we had this data, which was real data, but then we added this noise, which could be by bandwidth going up or down. And then also we had to add manipulations to the same data. So it was, detection is one part, data generation took a lot of time. And for the team, the user interface, that an IT person, let's say in a IT department of an organization, how he or she would be using this tool, how would they be reacting? Simply, if I say, okay, probability of something being fake is 85, that is not enough, right? What does that mean? 85 is 85 better than 84, or is equivalent to 86 or 87? So the visualization which we show, which can then inform the user to take a better decision, that is where we are focusing. Because with all this, there are privacy concerns as well, right? So let's say that we had some more people in this conference, and someone started using that tool without informing others. That is a privacy concern as well. So we are very mindful of these user interface aspect as well, and that is what the students and colleagues across IIT Ropar and Monash University are trying to understand. That we have these amazing algorithms, be that be generation algorithms or detection algorithms. How do we actually make them user centric? So that the goal is achieved, which is assisting the user.
It's a generally a complex problem you have. I mean, it might sound very direct, when you brand everything together under one deepfake, one nomenclature. But it's a very complex problem. Like when you mentioned, there's a privacy aspect. There is the data aspect. It's quite. So my question is, I mean, let's say we have started. I mean, finally we have started our fight against deepfake, and going forward, will tools like these will be our options fighting deepfakes? And if so, what are the chances of deepfake getting better than what we can detect them?
Well, the analogy can be drawn from virus and antiviruses.
Sure.
So certainly the quality of fakes is going to improve because there is a significant effort which is being put into generating synthetic data. And there are so many good use cases of synthetic data with respect to AI, so that is going to improve. Now, with respect to the deepfake detection part, see, one is only using machine learning. The other is using human in the loop. So, for example, last year we did a study where we looked at the eye gaze of the participants who were watching different type of fakes, like easy to recognize fake and deep fakes, which were high quality, difficult to recognize. What we realized is the eye gaze patterns were also different. So the user in the loop signals from him or her can also be added to a machine learning algorithm so as to improve it. And then the interaction part as well. So tomorrow, let's say we have extremely high quality, low computing resource deepfake generation tool, which one can use in a video conferencing solution. Even if a tool gives, let's say 75, 0.75 probability that this could be a manipulated feed coming in, the onus then is to the user. The user can ask a question, right? When I ask a question where I say, okay, can you describe something very positive from your life, right? Or what was the latest joke which you heard? Of course, you can't, crack the same questions in different meetings, but anything which is going to elicit a response from the user that may lead to facial movements, expressions, change in tone, then the tool can pick up those cues as well. So moving forward, detection would be requiring a human in the loop, because we never can have a computer vision, machine learning, or broadly, as we say, AI systems, which can understand the context. So we are a bit far away from those systems which can understand context, right? So that's why we need the user, and that is where even if the quality of fakes that improves, the detection would always be going hands in hand with it, because the human will come in the loop as well. So it would be detectors plus humans.
It's quite interesting, the work you have done, you and your team. That can you just brief us about that, your team? I mean, it would have been quite challenging collaborating with two universities across the continent. So how did that, and especially during this COVID time, so how did that happen, and who are the people who worked with you on this?
Right. So this whole different projects of deep fake, that is there are some academics a lot involved. So for example, there is Associate Professor Ramanathan Subramanian. So he is an HCI expert and works in AI as well. So he was looking towards the user interface and how to design the studies and those important aspects. Then we have this really I'll say hardworking students. Like for this particular project, there's Vineet Mehta, Parul Gupta, who were at IIT Ropar. Then there were students here at Monash who assisted in designing of the study, running of the system as well. So what happened actually is when the lockdown started, everyone went into online mode, right?
Yes, of course.
And that kind of blurred the time differences. So the time difference between India and Australia is not too much. It's either
Right.
4.5 or 5.5 hours. So that way, the team was actually able to work more, I would put in this way. There were more, asynchronous, but way more communications happening because everything is online. So it wasn't as difficult as one may foresee if the situation was not like this. So everyone, we adapt, right? So everyone has adapted this newer mode, and the students and academics using these video conferencing tools again, and also the different data sharing platforms like Slack or even WhatsApp as well. So that just helps in having a very active communication, asynchronous communication across different times. So I think we are more productive now.
So I mean, another thing, I mean, it's something you mentioned. Few days back, I had a conversation with Professor Sushmita Mitra of Indian Statistical Institute. I mean, she's one of the leading researchers in machine learning, and some other researchers from IIT Hyderabad. And there is this general theme, I would say, is taking something that done in the research facility and taking it into a production setting. That seems to be a hiccup, right? I mean, it's something people like Andrew NG has pointed out, in the race 2020 also, right? Like, it's not enough that we do these research projects, right? We need to get them into a production setting, right? In a usable thing. And you have said, for Fake Buster, you have already people reaching out to you to get into a production setting, to deploy this as a tool. So, can you tell me how that is going to happen?
So see, generally for any algorithm which we are making, or any use case using computer vision machine learning which we try to solve, either we go totally open source. We have these repositories on platforms like GitHub, and there we see interaction start happening with other university colleagues and industrial colleagues as well. There's another route wherein a lot of times startups or larger organizations, their labs, researchers would reach out, and from there would be a spark, and then a collaboration occurs. So I totally agree. There is no, the usefulness of any research done in oblivion within a closed lab, that would not do much good, right? So with more industry interaction, what we do is we go with different type of licensing, right? It's also possible that for this project or for other similar projects, sometimes a use case may require a bit more work, a bit different type of data. So we actively discuss with these industrial partners, and then either we work on it together or we just share after completing. So that's how we have been doing. But I totally second. So the respective professor at ISI Kolkata, and then IIIT Hyderabad as well, that we are now seeing a lot of interest from industry, which is very motivating. So the students are also then active, since they can get placed in those organizations. And for the organizations as well, they keep on doing their respective business, focus on that, and they can still keep on checking the different research projects. So that way, I think the ecosystem is improving quite rigorously. And it's also what at least I have observed, that as we have moved online, the rate of academia industry collaboration, that has just increased. That is going faster and faster. So we are hopeful that this kind of tool could actually be coming in picture with a video conferencing solution. But for that, again, we are hopeful that there would be someone who reaches out from a video conferencing platform end as well,
or Skype or Teams.
Or even I would be really delighted if an Indian startup or an Indian small video conferencing platform comes up and they would like to do something,
integrate it into the system.
So that we can actually, or even the Australian startup scene as well, so that we can actually add value to these hustler teams who can would like to quickly do and get things to market, and that's very exciting actually.
Because that will be also a unique feature, right? I remember a few years back seeing back. I mean, it is, I don't know, 5-6 years back, that Skype came up with this feature, like on live translation feature, and it was groundbreaking back then. So now, as our challenges evolve, the new feature will be, a live deepfake detection feature. I mean, it's quite unbelievable that we entered to imagine that we entered that era. So another thing I want to ask you is, you work between two very reputed universities. So what are the other projects you are involved? Anything interesting in terms of AI and machine learning?
Right. So one project which has been running for a few years is analyzing the perceived affect of a group of people from a well-being perspective. So let's say there is a group of people in an organization who are working around a machine, right? And anyways, we have CCTV cameras. So can we actually predict the affect? Affect is the current state of the mind, the emotional state. I try to not use the word emotions because emotions are too complex for AI to understand as of now. Whenever we do in effective computing as well, it's only perceived emotions. But coming back, so the project is essentially how can we understand the dynamics between groups? How can we understand the social relation? How can we understand the perceived emotion so that that can later assist into analytics, which can be added for a better work environment. So let's say if it's a construction company, right, and there are folks who are working on nth floor of a building, and that's a very stressful environment. They are working. So we anyways have these sensors. Can we look at the overall effect and see, for example, at this point of the day, these guys are not in the best of their energy and so forth. So that's one direction. We have investigation going on. It's a pretty new work which has started in the effective computing community. The other one is looking at eye gaze. Eye gaze is essentially I have a user in front of a computer. There is a camera, and I want to understand where is this person looking. So there are some commercial solutions as well which would use two cameras. But moving forward, looking at the how augmented reality and VR glasses, they are being easy, quite fastly adopted now. They're getting cheaper and better with rendering and stuff. So there, it is important that for the user interaction perspective, we know where is the person looking at. So with one of the PhD students, Shreya, we are investigating techniques for self-supervised learning. And for our viewers and listeners, simply self-supervised learning is that we have lots of data, let's say millions of data points, but we do not have any labels from a classic supervised setting. We do not have any labels. What we do is we try to generate labels from the knowledge about that data. So if we can have these labels, which are referred to as pseudo labels, then we can learn rich representations and then have models or networks which could be fine-tuned with a smaller amount of data. So that's one direction which we are looking at. And in the past, with colleagues, we were looking at depression as well. So how we can look at psychomotor retardation. So that is when the speech and the facial expression and hand gestures, they slow down if it is unipolar depression. Can we come up with an objective measure for that? So, but this line of research has been active for over a decade because it's a very complex problem. And there are multiple partners, multiple universities who are working on this type of, serious mental health issue as well. So yeah, so to name a few, these are the ones which are, going on.
Very, very interesting projects happening at your side. As much as we like to blame AI for deep fakes and everything bad, you have the other side of the coin where it's helping people improve their quality of life, solve problems, whether it's healthcare or education or environment. So it's quite exciting times in terms of technology we are living, to be honest. And I mean, I look forward to seeing more successful projects coming from you as a researcher. Like the successful, like the Big Buster, which has just came out. And I wish you all the success, for your work and going forward with all your research and everything else.
Thank you so much. It was a pleasure talking.